Assalamualaikum everyone. Today I'm starting from February March 21, which is the latest paper, and I'll be going backwards till 2011 or 2016. So the first one I'm doing is paper 2 for chemistry, AS level basically. So let's get started and let's move on to the first question. So the first question over here, it says the rate of chemical reaction is affected by changes in temperature and pressure. We know that, right? It is affected by changes in temperature and pressure. Draw a curve on the axes to show the Boltzmann distribution of energy of particles in a sample of gaseous krypton atoms at a given temperature. Label the curve T1 and label the axes. So basically, over here it is the temperature, and over here it is number or fraction of molecules. You can write either. So the graph is generally like this, and we have to label this curve T1. Alright, now let's move on to the second part, which says on the diagram in A1, draw a second curve to show the distribution of energies of the krypton atoms at a higher temperature. Alright, so what are we supposed to do over here? We have to label the second curve. So when the temperature is higher of a curve, let me draw it with a pen, or no, a pencil is fine. I can't find another pen. Alright, so when the temperature increases, the peak decreases, but the number of molecules with the activation energy increases. So basically, for example, if this is the activation energy for T1, the molecules with energy greater than the activation energy will be greater. So for example, if the number of molecules over here are 20, for example, over here they're almost 40. So same activation energy, but number of molecules are greater, and the peak is lower than this one because there are more molecules with the more number of molecules have higher energy at high temperature. All right, so let's get started. Let's move on to the next part. The Boltzmann distribution assumes that the particles behave as an ideal gas. State 2 is, so this is T2. I'm sorry, I didn't label it. Alright, so state 2 assumptions of the kinetic energy as applied to an ideal gas. So there are two basic assumptions. One is so there are a lot of assumptions, but let's just write two. So there is elastic collisions between the molecules, and the second one is the volume of gas molecules is negligible as compared to the volume of container. So these are the two assumptions, but you can always write any other. Alright, now let's move on to the next part. It says 2 gram of krypton gas, mass is given, MR is also given, we can say, volume is given, and temperature. We have to calculate the pressure. Alright, so what if we do PV is equal to nRT? We have pressure, we have to find out pressure, we have volume, we have moles and mass, we have 8.31 molar gas constant, and we have temperature. So we can calculate the pressure very easily. So P we don't know, volume is 5 dm cube, which is, okay, let's see, if this is basically 5 into 10 raised to the power minus 3, but if you cannot remember, just you know that 1 meter is equal to 10 dm cube, right? Sorry, 10 dm decimeter, and 1 meter cube will be equal to 10 raised to power 3 dm cube. So 5 dm cube will be equal to how much? 5 is equal to 10 cube x, so 5 over 10 raised to power 3 is 5 into 10 raised to power minus 3, because this will go up in the numerator, so it will be 10 raised to power minus 3 x. So this was very mathematical formula. You can just memorize this. You will memorize it with time after a lot of practice, but if you are not sure, you can always use this formula, unitary method basically. So moles, we calculate it with the formula, moles is equal to mass over mr. Mass is 2. I'm not sure what the molecular mass is. I think it's 39. I'm not sure. No, it's not. I can't remember. Sorry. So whatever the molecular, you can check it from periodic table. I am just writing Kr over here into 8.31 into 120 plus 273, because this needs to be written in Kelvin. So you'll solve this, then divide this answer with 5 into 10 raised to the power minus 3, and pressure will be found out. Now let's move on to the next part. Alright, so over here it says state and explain the conditions at which krypton behaves most likely as an ideal gas. So basically it behaves most likely as an ideal gas when the temperature is high and pressure is low. So basically, why is that? Because when temperature increases, so basically let me explain it to you. When temperature is increasing, so for example, this is a solid, right, in a container. Wait. We know that an ideal gas means that it has no intermolecular forces. We know that. No intermolecular forces. So when the temperature is low, it means it is in a solid form. So when it is in a solid form, it means it does have the intermolecular forces, which means that this is not behaving as an ideal gas. So when temperature is increasing, the solid converts into gaseous molecules. So they move far away, and the intermolecular forces become insignificant. All right. Now, pressure. Why does the pressure factor in? Because when the pressure is low, the volume is more. So pressure is inversely proportional to volume. So when the volume of the gas is more, it means they are not very close to each other. So it again means that there are no intermolecular forces, or very less intermolecular forces the in between the krypton gas molecules. So temperature is high and pressure is low to make sure that there are no intermolecular forces between the gaseous molecules. Now, okay, so I didn't write the basic reason, which you can always write. I have just explained it, so I didn't write it. Alright. So krypton reacts with fluorine. This is the reaction. Activation energy is this, and enthalpy change of formation is this. And what do we have to do? We have to calculate, we have to draw the profile, a reaction profile diagram. So over here it says enthalpy change of formation is plus 60.2, which means it is an endothermic reaction, which means the reactions will have a lower energy than the products. So the products will be over here, and the product is KrF2 product, and we'll draw an arrow from here to here, and from reactants to the highest point, it is the activation energy, which is 385 kilojoule per mole, and the enthalpy change is this. Enthalpy change is this. Plus 60.2. So the enthalpy change is in the upward direction. These both are in upward direction because it is moving from reactants to products. And for example, this is 50. So this must be what? 50 plus 60 is 110.2, right? So it is this, the reactants are gaining energy, so it is moving upwards. Otherwise, if it were losing energy, it would have been in the opposite direction. Right, now let's move on. Explain in terms of activation energy and the collision of particles how an increase in temperature affects the rate of chemical reaction. Alright, so we know that when the temperature increases, so the chemical reaction increases, reaction rate increases. Why? Because frequency of successful collision increases. Okay, so what it means is कि जब टेम्परेचर इंक्रीज़ हो रहा है तो रिएक्शन इंक्रीज़ हो रहा है. क्यों? क्योंकि फॉर एग्ज़ाम्पल एक ये नॉर्मल स्पीड पे जो है गैशियस मॉलिक्यूल्स फिर रहे हैं आराम आराम से, ठीक है. अब इनको हीट मिली तो इनकी वाइब्रेशंस और ये मूव करेंगे दूर, एक दूसरे से दूर होने के लिए, क्योंकि ये इधर को जाएगा, ये इधर को चला जाएगा, ये इधर को चला जाएगा, ये इधर को चला जाएगा, ये इधर को, ठीक है. तो कोलिजन्स जो हैं वो आपस में इनकी इंक्रीज़ हो जाएंगी. पहले थोड़ी थोड़ी हो रही थी, ये इसको टकराएगा, ये इसको टकराएगा, ठीक है. तो इंक्रीज़ हो जाएंगी तो एक्टिवेशन एनर्जी जो है वो डिक्रीज़ हो जाएगी, क्योंकि एक्टिवेशन एनर्जी क्या है, द मिनिमम अमाउंट ऑफ एनर्जी रिक्वायर्ड टू कैरी आउट अ केमिकल रिएक्शन. सो व्हेन, और केमिकल रिएक्शन होता कैसे, कोलिजन्स जब हुए, तो जब कोलिजन ज़्यादा हो रही हैं तो एक्टिवेशन एनर्जी डिक्रीज़ हो जाएगी, क्योंकि कोलिजन ज़्यादा हो रही हैं और रिएक्शन तेज़ हो रहा है. तो दैट इज़ द आंसर कि मतलब टेम्परेचर से कोलिजन ज़्यादा होंगे और कोलिजन से एक्टिवेशन एनर्जी कम होएगी, सो रिएक्शन रेट ज़्यादा हो जाएगा. सो लेट्स मूव ऑन टू द नेक्स्ट क्वेश्चन. Alright, over here it says chlorine is a reactive yellow-green gas. It is a strong oxidizing agent. And by the way, you need to memorize these because ये आ जाता होता है exam में, MCUs में basically. State how Cl2 is used in water purification. Alright, it is used to kill bacteria. Helps in killing bacteria. Alright. Construct an equation for the ionization. Alright, so what is the ionization? Ionization energy is the energy required when 1 mole of a gaseous atom loses an electron to form a gaseous monopositive ion. This is the basic formula, equation basically. Alright, so we need to write the ionization energy of chlorine. So Cl2 gas, Cl plus 1 gas, obviously, 2Cl minus. No, I'm sorry, this won't be the case. Only one chlorine atom will be present. Alright, let's move on. Explain the general increase in the first ionization of period 3 elements. So basically, in the periodic table, the atomic radius of sodium is this, and moving across the period it decreases. Let me explain it to you why this happens. So basically, firstly, ionization energy depends on atomic radius, shielding effect, and effective nuclear charge. Alright. Okay, so firstly, atomic radius is decreasing. Just assume, and just leave the reason. I'm just telling you that it is decreasing. Just trust me for a second. Alright. The shielding effect. What is shielding effect? The number. So when the number of shells increases, for example, this is the nucleus of sodium. The number of shells, I'm not sure how many shells are there. There are 11 electrons, so 2.8.2, so 3. So when they move down the group, the number of shells increases, which means the distance from the nucleus to the valence electron is lesser in sodium as compared uh, mm, to the lowest element in group 1. All right, so this increases, which means the shielding effect decreases because the number of electron shells are increasing, so there is less attraction to hold the for the nucleus to hold the valence electron, right? So down the group the shielding effect decreases. However, the number of shells across the period do not increase. The number of shells remain the same, so this won't factor in because this is remaining constant. So shielding effect remains constant, which won't affect the ionization energy. Okay, so the effective nuclear charge is increasing because the number of shells are remaining constant, but what is increasing? The number of electrons. So this nucleus, for example, this is the positive charge in the nucleus, it will attract these electrons more towards it. So this atomic radius decreases as compared to this, which has lesser electrons in its valence shell. So the nucleus does not have much attraction. All right, so this atomic radius decreases because the effective nuclear charge increases, and when this happens, this element has will require more energy for the valence electron to be removed, because the nucleus is holding on to the electrons very tightly as compared to this, which has a longer bond length nahi, a longer distance from the nucleus to the valence shell. So this nucleus will hold on to the valence shell more tightly. So this is what you're going to write over here, and that is it for today, and I hope you understood. And if you didn't, you can always comment and I'll reply to them, and please stay tuned for the next video, which will be up tomorrow. Bye bye.